Hello students, welcome to We Learn. Today we will learn about chemical reactions and equations from your chapter 1. So changes in our daily life. So consider these changes. When milk is left at room temperature during summer, when an iron tawa, pan or nail is exposed to humid atmosphere, grapes get fermented, food is cooked, food gets digested in our body, we respire. These are all the changes we see in our daily life. Okay, in detail we will learn. Okay, here this is activity 1.1. Here you were asked to take a magnesium ribbon and to clean it at first using a sandpaper. Okay, you have to clean it by rubbing it with sandpaper and then you have to burn it. Okay, while burning it, you will get some product. Okay, a precipitate will be you will be getting, and that precipitate has to be collected. Okay, and then we have to observe what is happening. Okay, that was your activity 1.1. Let us see what is the result we are getting out of that. See, on burning it, we will get a dazzling white flame. Okay, and it will get changed into white powder. Usually the ash will be collected in a white color. Okay, like this the ash will be collected. Okay, so this is because the reaction is taking place between the magnesium from the magnesium ribbon and the atmospheric oxygen. Here is a reaction. See, on burning magnesium ribbon, the magnesium will react with the atmospheric oxygen. It results in the formation of magnesium oxide. Okay, this is an unbalanced equation. We will learn about the balancing chemical equation in further classes. Next one is activity 1.2. You are asked to take lead nitrate in a test tube and to add potassium iodide solution into it. What will you observe? See here, on adding potassium iodide into a solution of potassium nitrate, an yellow precipitate is formed due to the formation of potassium iodide. So the lead iodide. Here the potassium iodide will react with the lead nitrate and it will result in the formation of lead iodide. Okay, that lead iodide will be in yellow color. So that yellow color precipitate is formed. Next one is activity 1.3. You are asked to take zinc granules in a conical flask and and into that hydrochloric acid or sulfuric acid has to be added. Okay, after that you have to observe what the changes is happening. So here when HCl gas is added to zinc granules, that zinc will react with HCl and forming zinc chloride. Okay, and it is an exothermic reaction. Usually exothermic reactions or the reaction where the heat is getting liberated. Okay, when heat is liberated, uh, the conical flask is closed here using a cork, right? So the reaction cannot liberate the heat out of the conical flask, so the conical flask will become hot. You can feel it by touching it. Okay, so from the above three activities we can easily observe some changes. That is, the first one is change in state. Okay, from the magnesium ribbon is getting changed to a solid state. Next one is a change in color. In activity 1.2 you can easily feel that a lead iodide, okay, PbI2 is getting formed, right? That is in yellow color, so change in color is taking place. Next one is evolution of gas. In activity 1.3 we can easily see that on adding hydrochloric acid to zinc granules, H2 gas is getting evolved and that results in the change in temperature because it is an exothermic reaction. Next one is writing an equation. So first activity 1.1, magnesium reacts with oxygen, will form magnesium oxide. This is a word equation. We are going to see how we are going to write it in a chemical equation. First one is magnesium, Mg, is reacting with oxygen O2 and results in the formation of magnesium oxide. This is a product. On activity 1.2, see lead nitrate is reacting with potassium iodide and that gives lead iodide plus potassium nitrate. This is a chemical equation. Lead nitrate means PbNO3 twice. Potassium iodide means 2Ki. Lead iodide means PbI2. So this is a yellow precipitate. That's what we're giving a downward arrow. Okay, next one is potassium nitrate, KNO3. Next one is activity 1.3. See, we see that zinc, in previous case, we saw how HCl, it will react with HCl gas. Here, when it reacts with sulfuric acid, zinc sulfate is formed. When we add HCl, zinc chloride is formed. Here, zinc sulfate is formed and H2 gas is getting liberated. See, this is the chemical equation: zinc plus sulfuric acid. The chemical formula for sulfuric acid is H2SO4. That results in the formation of ZnSO4. SO4 means sulfate, okay, and H2 gas is formed. Next, we are going to see about balanced chemical equations. See, let us take the previous equation. Zinc is reacting with the sulfuric acid, and that results in the formation of zinc sulfate plus H2 gas. First, let us uh, examine the number of atoms, atoms of different elements on both the sides. So let us see, we have four kinds of element, right? Zinc, hydrogen, sulfur and oxygen. Those four were listed here. First, let us see in reactant how many elements we have. So zinc, only one zinc is there, two hydrogens are there, one sulfur and four oxygens are there, right? In product side, we have one zinc, one sulfur, four oxygen and two hydrogens. Okay, so here see, one zinc and one zinc, two hydrogen and two hydrogen, one sulfur and one sulfur, four oxygen and four oxygen. See, the left hand side and the right hand side number of atoms of each element are same, so it is a balanced equation. Like this, if any equations are given for your public exam, means you should know how to check whether it is a balanced chemical equation or not. Okay, if it is equal, when the number of atoms of reactants is equal to the number of atoms of the products, means it is a balanced chemical equation. If it is not equal, means it is an unbalanced chemical equation. This is an important question for your board exam. Next one is balancing a chemical equation. If it is an unbalanced equation, means we should know how to balance it. The first step is you have to box it. Okay, you have to box each and every formula. Okay, next one is like previously how we did, we have to list the different elements present in the chemical equation. First, we have iron, hydrogen and oxygen. Okay, then in number of reactants and number of products, we have to see how many numbers are there. Here in reactant, we have one iron, two hydrogens and one oxygen. In product, we have three iron, four oxygen and two hydrogens. Okay, here it is an unbalance, we have to see how to balance it. Okay, in step 3, we have to see which contains the maximum number of atoms. So here in the chemical equation, we have Fe3O4. Okay, in Fe3O4 we have oxygen. Okay, oxygen is present in high number, so we are taking it. You see, in reactant we have only one water. Okay, in this we have only one oxygen in water. Next we have four oxygen in Fe3O4. So here four oxygens. No, so here it is four. We are going to balance it. Only one oxygen is there in reactant, but four oxygen is there in the product side. So we have to multiply the reactant by 4, so that both will become 4, right? Here it is the balanced equation. 4, we are multiplying this water, okay, with 4. Next one is this is the product. Okay, so after the initial step of multiplying, we are getting this equation. Okay, and on further we are going to see the other thing which is left. Here we are taking hydrogen. Okay, from that equation, see, from this equation now we have high number of hydrogen only. Okay, here we have 8 hydrogen, 4 twos are 8, right? So we are taking up the hydrogen. So in reactant we have 8 because 4 water molecules are there, 4 twos are 8. So 8 hydrogen atoms in the reactant molecule, and in product we have only 2 because H2 is there, right? 2. How to equalize this, how we can bring this 2 to 8? Only by multiplying it with 4, right? So here see, we have multiplied it with 4. Okay, so Fe plus 4H2O gives Fe3O4 plus 4H2. Next we will see what element is left. Only iron is left, right? But in reactant side we have only one iron. See, here we have only one iron, isn't it? Here in product we have 3 iron. In Fe3O4 we have 3 iron, right? So how we can balance it? Only by multiplying the reactant side by 3. So this is 3Fe plus 4H2O will gives Fe3O4 plus 4H2. Now we have to check whether it is a balanced one or not. So 3 ion. This is the reactant side. We have 3 ion. In product side also we have 3 ion. Then reactant side we have 8 hydrogens. In product side also we have 4 twos are 8. So 8 hydrogen. Here we have 4 oxygen. Okay, 4 oxygen. And here also we are having 4 oxygen. So it is a balanced equation. So like that, if an unbalanced equation is given, you have to balance it using this method. Next, we will learn about writing symbols of physical state. Okay, not only the balancing, but also sometimes you might be asked to balance it by using the physical states also. For gaseous state, G is added. For liquid state, L is added. So aqueous state means that is in solution with water. Okay, so AQ is added. For example, see, potassium iodide or potassium hydroxide is dissolved in water, means we will give potassium hydroxide or potassium iodide aqueous. Aqueous means it is dissolved in water. Next one, solid means, yes, see here 3 ion is in solid state and 4 water is in gaseous state. Gaseous state means it is in steam. Okay. Okay, gaseous state means it is in steam. Next one is iron oxide. Iron oxide is given in gaseous state and hydrogen is in iron oxide is in solid state and hydrogen is in gaseous state. Here the G symbol means it is in gaseous state. So steam. Water is taken as steam in this equation. Next one is not only this but also the temperature, pressure and catalyst will also be indicated upon or below the arrow mark. See, look at this equation. Here 340 atmospheric pressure is given. So pressure is indicated like this. Next one is sunlight. In presence of sunlight, and chlorophyll is reacting as a catalyst here. So like this, the conditions like temperature, pressure and catalyst and all given upon or below the arrow mark. Okay, so these are the questions. So first one is, we saw in activity 1.1 that magnesium ribbon has to be cleaned right before burning it, because see, magnesium is highly reactive with the atmospheric oxygen. Okay, so magnesium will react with the atmospheric oxygen. Before burning itself, the layer in that ribbon, a layer of magnesium oxide would have been formed, which will not burn. That will protect the inner layer of magnesium from burning. So we have to clean it using a sandpaper, then we have to burn it. Okay, next one is balancing the chemical equation. Hydrogen plus chlorine will give hydrogen chloride. Okay, so H2 plus Cl2, you can say hydrogen chloride or hydrochloric acid, both are same only. Next one is barium chloride on reacting with aluminum sulfide will give barium sulfate plus aluminum chloride. So barium chloride, aluminum sulfate will give barium sulfate plus aluminum chloride. Next one is balancing a chemical equation. Okay, so solutions of barium chloride with the physical states. With the physical states, you are asked to write. See here, barium chloride and sodium sulfate in water. Okay, so barium chloride, water means we have saw that we have to write aqueous, AQ, and sodium sulfate is an aqueous state. Will gives barium sulfate. Barium sulfate is in solid state and sodium chloride. Okay, so solid state means it is getting precipitated. Precipitate means we have to give downward arrow. If gas is getting liberated means we have to give upward arrow. Give sodium chloride. Okay, this is the chemical reaction, balanced chemical reaction with the physical state. Next one is sodium hydroxide. Sodium hydroxide is an aqueous state in water. Okay, aqueous state means in water, and HCl in water to produce sodium chloride. See, sodium chloride is an aqueous state plus water. Water is a liquid. So this is the balanced chemical reaction. Okay, see, without seeing the answer, you can try of your own, children. Please like my video, share and subscribe. Thank you.